Today's video will explain the chain of responsibility design pattern. Hello, I'm James Helfrich. The chain of responsibility design pattern is useful when more than one part of the program can handle a different update or issue. This video will define the chain of responsibility design pattern, show how to implement it in a UML class diagram, and show how to integrate it to solve many interesting problems. The chain of responsibility design pattern is a communication strategy where multiple handlers get a chance to consume a message or pass it on to the next handler in the chain. Essentially, it is a linked list of handlers, each of which is given an opportunity to handle a request. If the request is handled, then the process terminates. If the request cannot be handled, then it's passed to the next node in the linked list. So before we implement this design pattern, imagine a company of soldiers. And right now, if anyone has any question, they talk directly to the captain, which is really, really difficult. Instead, the corporal should talk to the squad leader. Now, if the squad leader can handle it, then we're finished. The answer goes back to the corporal. But if the squad leader cannot handle it, it gets passed up to the sergeant, and the sergeant can handle most of these, and then it passes it back to the corporal if it's handled. But if not, then it's going to pass it up to the lieutenant. The lieutenant will deal with these, but of course, if something the lieutenant cannot deal with, and then and only then will it make it up to the captain. In this way, there's an order in which things are handled. So we'll start with an object diagram. First, Private Pyle will try to deal with the complaint. If he cannot, then the squad leader Smith will try to handle it. If that fails, then Lieutenant Lewis will give it a go. And finally, only the most severe complaints arrive on Captain Campbell's desk. So we have Private Pyle, and if Private Pyle cannot deal with it, he'll send it to Squad Leader Smith. And if Squad Leader cannot deal with it, he'll send it off to Lieutenant Lewis, and then finally off to Captain Campbell. Now notice the vast majority of the complaints get dealt with early in the chain, and only the most severe would make it to Captain Campbell's desk. All right, let's take a look at the class diagram. We're going to start with the client, and the client is going to have a handler reference. So we have to have the abstract handler. Now, how is the client going to be related to the abstract handler? Through association, and there'll be exactly one. Now, the abstract handler will have a pointer to the next abstract handler, and this is how we do the linked list. So there'll be 0 if this happens to be the end node, and 1 if there's a node after us. Now we're going to have a set next, so we can add a new element to the linked list, and we're going to have the handle request. Now notice the handle request is a pure virtual function, which means the abstract handler is an abstract class, hence the name abstract handler. But so if I have a pure virtual function, I must have at least one derived class. In this case, I'm going to have 2, concrete handler 1 and concrete handler 2. So let's take a look at the pseudocode for initialize. I'm going to create 3 different handlers, and I'm going to set next, set next, set next, and that's how I'm going to build my linked list. And my pseudocode for set next is I'm going to say the next pointer is my abstract handler. And of course, when I want to handle a request, I first got to see if I am able to handle a request. In other words, am I qualified to deal with this event? If the answer is yes, then I will call handle request here. Otherwise, I'll call handle request on the next one in the chain. Now, it turns out there's another easier way to do this. Instead of the client having a single pointer to the abstract handler, I can instead have a collection of abstract handlers. So therefore, I'm not going to have one by aggregation, but rather I'm going to have many. My abstract handler is not going to have a pointer to the next abstract handler. In fact, it'll have nothing at all. And then I'm also going to get rid of my set next. Now, the key is my handle request is now going to have to return a bool. What this means is I'm going to loop through all the abstract handlers that are in my collection. And then if it ever returns true, then I stop there rather than move on to the next. So let's go back to our Marine Corps example here. So I have an individual who may log a complaint. And so I need to have a complaint type by aggregation. And this is going to have a pointer to the next complaint. So it's going to be 0 if this is the last one in the list, or 1 if there's more than one. And then I'm going to have Captain Campbell's complaint inbox, Lewis's complaint inbox, and other words. And all these are done by inheritance. So my pseudocode, so Captain Campbell has no next, so the buck stops with him. He's the last person in the list. Lewis complaint, after him comes Captain Campbell, and Smith complaint, after him comes Lewis's Campbell. So here's a second example. A calendar application is tasked with moving to-do items onto a schedule. Each item has a duration and a priority 1 through 5, and the algorithm should first schedule all priority 1 items, then move on to priority 2 items, and so on. So we have the client, which is going to have the schedule, and the scheduler, which is going to point to the next one. So clearly the client is going to have 0 or 1 scheduler. Next is going to point to itself. And then we have schedule 1 priority, schedule 2 priority, schedule 3 priority, and so on, all these by inheritance. First of all, we're going to handle everything that's priority 1. And then if there's anything left, then schedule priority 2. Then if there's anything left, then schedule priority 3. And finally, if we're lucky, we might be able to do priority 5 things at the very end. We can also do this with the alternative implementation. Instead of pointing to 1, we're going to point to many, and the scheduler will then get rid of its linked list. This is example 44.2 in the chain of responsibility section of the message passing chapter of the software design textbook.